Okay, saying that really quick again. Here's quadrant 1, quadrant 2, 3, 4. Here we go. X, Y points. So you always graph X first, everybody. Over 2 up 3. So A would be in what quadrant? Quadrant 1. So we're plotting this X, Y point. So I'd go -7 down 2 units. True? So that would be in quadrant. Okay, good. And then right here, over -5 up 4 units. It's hard to see. And that would be in quadrant 2. And then let's look at this one. Over 0, down 3 units. That is not in a quadrant. That's on the y-axis. If it falls on an axis, just say the y-axis. And then be specific. It's on the y-axis between Q3 and Q4. The y-axis between Q3 and Q4. Everybody see? Okay, awesome. Okay, let's look at this one. So it says, given this equation, determine if the following x, y points are on the graph. So I want to point out, this is in the form 3x minus y equals 6. It's not in y equals form. We don't need to do extra work though. We don't need to put it in y equals form. We can test it right here, right now by plugging stuff in. So this is an xy point. This is a line. How do I know it's a line? Because look, x is degree 1. Does everybody see? So it's linear. So if I plug this in, this point in, and it comes out a true statement, if I was to graph this, this point would be on the graph. So let's just test it with algebra though. So plugging in for x equals 2, so we would have 3 times 2 minus y is 0. Notice I'm using parentheses equals 6. So wouldn't that be 6 minus 0 equals 6, 6 equals 6? Yeah? Is that a true statement? Yes. So if we were to graph it, that point would be on the graph. Make sense? Okay, let's look at this xy point, plugging it in. So we would have 3 times 1 minus parentheses -2 equals 6. So that's 3. Then this becomes a plus 2 equals 6. Isn't that 5 equals 6? It doesn't equal 6. Therefore, if we graph it, this would not be a point on the graph. Make sense? And let's do this one, 1/2. We have to be able to do fractions by hand. So it's really not too bad. Let's plug this in. So we have 3 times 1/2 minus parentheses -9/2. And that needs to equal 6. True? So guys, how do we multiply fractions? Remember, this is really 3 over 1. You multiply straight across. So that would be 3/2. Do you see? So we have 3/2 minus, oh, what does that become? Plus 9/2, that's equal to 6. Now you need a common denominator to add fractions. So let's put these together. Well, we can because they have a common denominator. 9 plus 3 is? So we have 12 over 2 equals 6. 6 equals 6. Yes, so this point would be on the graph. Makes sense, everyone? Moving on to the next one. Okay, we're going to be asked to graph a bunch of different types of equations. But you don't have to do it like Sec 3. Sec 3 we memorize, oh, this is what a line looks like and this is how we do it. This is how a cube looks like, this is how we do it. We're staying really basic. This is just 10-10. We're going to just plot x, y points when we're asked to graph. So, when I say graph this line, you're not going to do the mx plus b thing. You're just going to plot points. So pick 5 points. You need to plot at least 5 points. So -2, -1, 0, 1, and 2. I just choose those because they're nice and pretty a lot of times. So let's plug in -2. Now think about how functions work. If I take and plug in -2, don't I get out some y value? Yes. Okay, let's plug in -2. So showing my work here. -2 times -2 plus 4. 4 plus 4 is 8. So we have -2, 8 on the graph. Plugging in -1. -2 times -1 plus 4. 2 plus 4 is 6. Plugging in 0. -2 times 0 plus 4. 4. Plugging in a 1. -2 times 1. -2 plus 4. 2. Plugging in a 2. -2 times 2. -4 plus 4. 0. Now guys, if we needed to plot more points, we can always put a 3. We can keep going. If you can't graph it, then just plot more points. But it looks like we're good. So watch, -2 up 8 units. Over -1 up 6 units. True? Over 0 up 4 units. Over 1 up 2 units. Over 2 up 0. Now it's a line. Degree 1. So it's looking good. It's kind of nice to have in the back of your mind what it should look like. It does look like a line to me. Now I need another point over here to fit the graph perfectly. So you could just kind of cheat and say, aren't we always going down 2 over 1? Down 2 over 1, down 2 over, oh, yeah, down 2 over 1, down 2 over 1. So down 2 over 1, down 2 over, down 2 over 1, down 2 over 1. And that, we've listed out at least 5 points, so that's good enough. Arrows, because it is continuing forever. Yeah, if on a test, you'd have to make it fit the entire graph that can plot whole number points. Okay, looking at this one. Once again, just watching might be enough for you at this point where you know how to graph. We're just graphing by plotting points. However, we do know quadratics are used, correct? Okay, let's plug in -2, -1, 0, 1, and 2. So -2 squared is -2 times -2. 4, -1 squared. 1, right? 0 squared is 0. 1 squared is 1. 2 squared is 4. So -2 up 4 over -1 up 1 over 0, 0 up over 1 up 1 over 2 up 4. And then let's say you're like, should I plot something else? Plug in a 3. 3 up 9. So over 3 up, oh, well, it doesn't fit, so we don't need it. Do you guys see? So then I would just connect it. All is good. Yeah, but we're not getting into that at this level, plotting points, not thinking that advancedly. But yes, yeah. Okay, moving on. So what if it looks like this? 2x plus 2y equals 8. You could do extra work and solve for y right here, or you could just simply plug it in, plug stuff in for x, just like we did before. So isn't it linear? It's just not in mx plus b form, right? Why is it linear? Degree 1, right, everybody? But let's just go right here, -2, -1, 0, 1, and 2. Let's just plug it in right here, right now. So we would have 2 times -2 plus 2y's equals 8. So isn't that -4 plus 2y's equals 8? So wouldn't I add 4? 12 divided by 2. Okay, good. -1. 2 times -1 plus 2y's equals 8. So we have -2 plus 2y's equals 8. So we'll add 2, we get 10 divided by 2. 5, plugging in 0. 2 times 0, right? Which is 0. So we just have 2y equals 8. 4. Plugging in a 1. So wouldn't that be 2 plus 2y equals 8? Subtract 2, we get 6. 6 divided by 2 is 3, and then plugging in a 2. 4, subtract 8. 4 divided by 2. 2, and then we would plot the points. It should be a line, right? So if you have something weird, you've just done something wrong. Do you need me to plot the points, or do you guys know how to plot points? You're good. Don't waste our time. What do you need? Moving on. Okay, so looking at this. Now notice something's interesting on this one. X equals y squared. In all these, it was y equals. Well, it's fine. It's just this time, instead of plugging things in for x, we're going to plug things in for y. If this was secondary 3, I'd have you square root both sides to get y alone and not forget a plus or minus. But we are not doing that advanced stuff in this, like right at this level. Let's just do it this way. So instead, we're plugging in something for y and getting out our x. Does everybody see? So instead, we're going to put y values. That's what we're going to, we're going to pick y values. We can pick any x, y points we want. Does everybody understand that? So I'm going to go with -2, -1, 0, 1, and 2. But now those are our y values. It works the same way though. -2 squared. So our x value is 4. -1 squared. 0 squared. 1 squared. And 4. And now we'll graph those points. So over 4 down 2 units. Over 1 down 1. Over 0, 0. Over 1 up 1. Over 4 up 2. Now look, isn't that a sideways parabola? Everyone? Which actually makes sense, because if I did solve for y, I would square root both sides. So I'd get y is equal to plus and minus root x. Square roots, look, if I cover up this bottom, isn't that the positive square root? That's the negative square root. So it's making sense, it's just we're not doing it the hard way. We're just plugging points in. Okay, what would I do for this one? X is equal to y squared plus 2. Should I plug it in for x or y? Y, so we'll -2, -1, 0, 1, and 2. Plug in -2. -2 squared is 4 plus 2, and -1 squared. Plus 2, 0 plus 2, 1 plus 2. And then 4 plus 2. 6, so I could graph those points. Won't it be another sideways view? Okay, cool. Okay, so guys, you're not always going to have on tests worded the exact same way as a homework. So you got to just be able to put 2 and 2 together. What's this asking? So let's read this. If a comma 4 is a point on the graph of y equals 4x minus 3, what is a? What is this asking you to find? X, in a very just weird way. It's asking you to find x. So how could I do that?
Plug in 4.
Yep. This is an xy point, so we can take and plug in 4 in the correct spot. So we have 4 is equal to 4x minus 3. Now can't I solve for x? Add 3. So 7 is equal to 4x, divide by 4. So then our x value must have been 7/4. So a was 7/4. Just put 2 and 2 together. Think a little bit. All right. Now let's talk about how you should write x and y intercepts correctly. So x-intercepts are where it intercepts the x-axis. Y-intercepts are where it intercepts the y-axis. So now guys think, people always get this backwards, but just think a little bit. We always go x, then up y. Over x, up y. So my x-intercept would be over -3 up 0. We always write them as points. Over 2 up 0. We do x first always. Over 6 up 0. There's our x-intercepts. Now with y-intercepts, you say, okay, I'm going over 0 and then down 2. So we went over 0, but then down 2 units. Does that make sense, everybody? All right. Okay, we're almost done with this part of the lesson. So here's the thing, guys. We have to be able to interpret graphs. It's very straightforward. It's not super advanced at this point in the year. So it's just seeing if you understand that graphs can represent, can show like a relation of 2 things. So let me just give you an example here. This is the number of gallons of oil, and then this is the cost, the amount of money of the cost in $100. Now let's think about why this is only in quadrant 1. Would we ever, so we have a certain number of gallons and it's going to cost us an amount, right? Could we have a negative amount of gallons of oil? No, that wouldn't make sense, would it? So we only can go positive x. Now, let's say we went positive x. Could we go down? If you have gallons of oil, will it cost negative money? No, it's going to cost positive money, right? So this is why it's only in quadrant 1. Okay, here we go. So if I said to you, how much does it cost if you have 0 gallons? 0, which see, it makes sense. $0. Okay, so if I have 1 gallon, how much will it cost me? Wait,
$100.
200?
Yeah.
$200. If I have 5 gallons, how much would it cost? $700. It's just seeing if you can put 2 and 2 together of what a graph means.
So it's analyzing.
Yeah, analyzing. Okay, let's look at this one. So it says this is the area, this represents area of a window based on the width of the window. So width of the window will cause an area. So here we're looking at a window in a house. Here's width, right? Width. Okay, so right here, this is 0 width, and how much area would 0 width have? 0 area, right? It makes sense. Okay. Awesome. So let's answer part A. So this is over here at how much? 10 feet or whatever. Does that make sense? And if you're at 10 feet, the area of the window would be 400. Okay. So A says, what is the area of the opening if the width is 10 feet? We just said it. 400. Okay. B, what is the width of the opening in order for the area to be at its maximum? Yeah, it would be the top point. This is the highest area, true? So what would the width of the opening be? 25, right? Look, x, y, it gives you a hint. And then it says, what is the max area? So at 25, the max area is 625. Does that make sense, everybody? Okay, now let's see here. It says identify and interpret the intercepts. So here's an intercept, and here's an intercept. Let's think about what those represent. Interpret the intercept. Think, what does it represent? Say it again. You're on the right track, yes. I think, yes. And on the right track. What do you think they represent? I've had somebody get it every hour. What does 0 represent? When we're at this part of the window, true? Yeah. So what does the 50 represent? The other side of the window, people. The largest we could be is 50. Do you guys see? Does that make sense? So it's the other end of the window. Because at that point now, we're back down to, if I said find the area at that point, it'd be 0. Okay, cool. All right, so now I'm going to give you a second to practice a couple on 2.1 from the homework. Ready, set, go. Now we're going to be dealing with input and output of functions, which we've already pretty much been doing in 2.1. So input and output. If we have a function, we can plug in something, we get something out, right? That's how functions work. So for example, f of x is equal to 2x squared minus 5x. That's our function. We can plug in 1, x equals 1, and we get out some amount. Does everybody see? So if it asks you what's my input, you would say x equals 1 is an input, and what do we get out? And then that would be our output. So let's 2 times 1 squared minus 5 times 1. So 1 squared is 1, 2 times 1 is 2, 2 minus 5, negative 3. So we get out y is equal to negative 3. Does everybody understand? Now, here's also some wording that we have to know. Dependent. So, and independent. So x equals 1. We randomly chose that. Like, that's independent from anything. We can pick any number here. Then we plug it in, and we get some answer out, which depends on what we plugged in. Do you guys see? So we only got negative 3. That was dependent on the fact that we plugged in 1. So does that make sense, everybody? Yes? Okay. Then that's also called domain and range. So domain's what you plug in, or x values, range is what you get out. Does that make sense? How functions work, right? Okay. Sweet. Let's plug in 0. I'm going to change colors here. So input, let's input x equals 0. That's independent. X equals 0 is x equals 0. Great. Plug it in. What do we get? Out. 2 times 0 squared minus 5 times 0. 0. True, everybody? Yes. Okay, we got out 0. So that was dependent on the fact that we plugged in 0. And then our domain was 1 and 0. Our range was negative 3 and 0. Okay. Now this is a relation. This was a function. This is a relation. So it works the same as a function. We're starting with heart and we go to love. Starting with heart, we go to love, just like we started with 1. So our input here would be heart. Our output would be love. Our input would be 2. Our output would be number or hashtag, whatever. Make sense? Okay, cool. Now, here's the thing. We can have things that are considered quote-unquote a function versus considered not a function. So remember the one rule. If it's really considered a function, then this happens. Each input will only have one output, or each x value will only have one y value. Each x can only have one answer y. Does everybody understand? Okay, so let's see if each of these examples are considered a function. How about this one? Age and cholesterol. This x, does it have one y? Does this x have one y? Does this x have one y? And this x? Yes, so we're good. This one would be considered a function. Now let's look at this next one. Animal and their life expectancy in years. Dog has 11 years, correct? Yeah. Cat also has 11 years. However, each input can only have one output. Doesn't dog only have one answer? Yeah. Cat only has one answer. We're still good. Duck to 10, lion to 10, pig to 10. All the x's still only had one answer. Do you guys see? So this one would be a function. Now here is a bakery and the cost of their goodies. So a sugar cookie can cost $2 and a sugar cookie can cost $3. Doesn't that x have 2 y's? So this is not a function. It can happen, but it's just not a quote-unquote function. Does that make sense? This is still input, this is still output, it's just not quote-unquote a function. Peanut butter had 2 answers, so it was not a function. Okay, keep going, tell me if these are functions or not, making sure we're good. Is this one a function? Yes. Is this one a function? No, because of? Smiley face. Okay, good. How about these points? A function or no? Yep, -3 to 3, -2 to 2, -1 to 1, 0 to, and then do you guys see? Every x only has 1 y. My domain would be my x values, true? And then my range would be my y values. Okay, good. What about this bad boy? Why do you say no? -3 and -3, so we have a -3 that has an answer 2 and an answer 6. Bad news, bad news. Yeah, that's good. That's good. So then you'd say this is not a function. However, this is still the domain. This is still the range. It's just not a function. Okay? We could still plot the points, could we not? Yes, we could, right? So it's still there. It still exists. It's just not a function. Okay, so now given an equation, it wants you to determine whether the equation shows y as a function of x. That's a fancy way of saying, can we consider this a quote-unquote function? So remember, for each x, there can only be one y. So let's look here. Here's a line. If we plug in some xy points, are we going to get more than one answer out? So let's plug in 0. If we plug in 0, what do we get out? 5. Was that only one answer? Would there be any other possibility? No, or else it would have been solvable. If I plug in a 1, you better plug in more than 1 point. If I plug in a 1, what do I get out? 8. Now think about it. If I plug in any number, won't I only get one answer out? Yeah, so this one would be considered a function, which makes sense. It's a line. Lines are functions. Right? Lines are functions, everyone? Okay, cool. Let's look at this one. So x, y. If we plug in 0, 0 squared 0, plus and minus 0 is just 0. You better plug in more than 1 point though, maybe 2 points. So if we plug in a 1 here, we get 1 squared, right? Yeah. But now we have a plus and a minus. So 1 is to 1 and to -1. So this is not considered a function. You can still graph it, but it's not a function.
Is that the only time it will be a function?
Yeah.
Really?
Yes. Yeah. So let's look at this one. So this one's not in y equals form, but we could still go about it the same way, x, y. So let's plug in some values for x. Let's plug in 0. So we have 0 plus y squared equals 9. Let's see what we get out. So we would have y squared equals 9. What squared equals 9? Yep. So when you square root, you need a plus or minus, right? Y is equal to plus and minus 3. Or you just think about it. You'd say 3 squared equals 9, but also -3 equals 9. So this had 2 answers, 3 and -3. So this one's not a function. Yes. Yes. All right. Looking at a picture, are these a function? So this is what people use, what's called the vertical line test. That just means if your pencil is vertical like this, is it hitting your function in 2 places? Is it hitting your pencil in 2 places on the y-axis? So if we, not on the y-axis, on our y's, just in general. So as I go through here, is it ever going to hit my pencil twice? No. Now don't be mistaken. Quadratics go like this forever, right? They're not going to go back on themselves. It might get really steep, but it's not double dipping. So this is a function. How about this one? No, because look, if I draw my pencil, it's hitting it in 2 places. Not a function. How about this one? It hits my pencil in 1, 2, 3 places. That's not a function. How about this one? Yes. Look, it never hits. Look, if I draw it, does it ever hit twice? No, so this one is a function. Okay, so if I said to you on the homework, find the indicated values for the function, what would I do if I said f of 1? Plug it in. So that'd be 1 squared minus 2 times 1. 1 squared minus 2 is -1. True? Plug in 0, we get 0. We know how to do this. What if right here, I asked you to plug in -3, what would you get on bottom? 0. So our answer would not be 0. What would our answer be? It wouldn't be 0, it would be undefined. If you can't divide by 0, everybody. Okay, now it's going to ask you in 2.3 to graph. Once again, we're doing it back to basics. Just plot XY points. Is everybody good with that? So I pick points, pick points. Now, it is nice to remember what graphs look like because then you can kind of see if you've done something wrong. Remember, absolute values are sharp V's. Just because it's kind of nice, I had somebody come and get help yesterday, and then when they were graphing, they're like, well, it should be a V, so I've made an error somewhere. So it just helps to kind of keep in the back of your mind what the function looks like. If you can remember. If not, just plot points to the best of your abilities. Something to the third power looks like this. Just a reminder. It's kind of nice to have it in the back of your head so you know if you've made some weird errors. Okay, cool. So what I'm going to have you do now is practice that one before we move on. You need to do the same type of stuff. Okay, so now 3.1 is going to take a focus on linear equations and linear functions. In our other examples, we were seeing all types. We were seeing absolute values, we were seeing degree 2, right? This one's just taking a focus in linear. So this is two different forms. You can see a line in. This is called, right here, is called standard form. And this is called slope-intercept form. Not one is better than the other. Literally not one is better than the other. It's just, basically, you could do either or. So it depends on the problem. So like, for example, I'm showing you 3x minus 4y equals 9. That's in standard form. That's not very ugly. That's kind of pretty. But let's put it in slope-intercept form if we really so desired. What do we subtract 3x over? Subtract 3x. So we would have this, 9 minus 3x. So then because I want it in mx plus b, I put the mx part first. Do you guys see? Negative 3x plus 9. And then what would I do next? Divide by negative 4. So I would have this. Now, if I wanted to put it in mx plus b form, they would split it up. So as long as we divide both of them by 4, or negative 4, it would be okay. So negative divided by negative is a positive 3/4 x, right? Positive divided by a negative is minus 9/4.
Yes.
That is hideous. Shouldn't we just probably have stayed here? So it just depends on the problem, really. So let's look at my first example. It says graph by plotting points. Haven't we already done that?
Yes.
We would literally leave it like that. We would just plug in values for x, just like we did before. So then we would have 4 times negative 2 plus 2y equals 6. So then we would have negative 8 plus 2y equals 6. So then we'll add 8, we get 14. Divide by 2, we get 7. And we've already seen this before. So I don't need to keep going. Do I? Because I can. No different than the last two parts of the lesson. Okay. Now everybody, isn't it degree 1 linear? So if you're all over the place, something's off, right? Should be linear. Okay, what about this one? Same thing, right?
Yes.
Okay, now let's talk about if these vertical and horizontal lines. It says graph x equals 2. Guys, I remember when I was young, I used to get so confused by these, and I would try to memorize, oh, x you do this, y you do this, and it's confusing. You mess up. So instead, just make sense of it. When I made sense of it, I never messed up again. So everybody, this says x is always going to equal 2. Do you see? So I'm going to go to x equals 2. No matter what, x can only equal 2. Do you see? Y can be anything, but x has to be 2. So that would make the line look like this. Oops. Now look, why does that make sense? Over 2 up 1, over 2 up 2, over 2 up 3, over 2 down 1, over 2 down 2. Do you see how x always is equaling 2? So I know I've drawn my line correctly. So same here. X is always equal to negative 5. So you'd say, okay, I can't change. My x always has to be at negative 5. Does that make sense, everyone?
Yeah.
Negative 5, and we have all those y values. But x is always negative 5. Okay, so what if it's y equals 5? Now you have to say, y is always 5. Here's my y-axis. Y can only be 5. It can't go anywhere else. It has to be right here. But x can change. It didn't say anything about x. Y has to be 5. Now look, it makes sense. Over 1 up 5, over 2 up 5, over 3 up 5. Y is always 5. Okay. Y is negative 6. Sweet. So what if I asked you to, what's the domain? You would say, all real numbers, correct? What's your range? 5. No, 5. 5, right? 5 only. Didn't we say that y was only 5?
Yes.
Does that make sense? Okay, cool. This one would be considered a function, wouldn't it?
Yes.
Would this one have been considered a function? No. Look, my pencil has a bunch of dots overlapping. We can still draw it. It's just not considered a quote-unquote function.
But with that one, but they're different functions itself.
Oh, I was just, yeah, we're pretending like just one of them is graphed. My bad. I see your question. Okay, so let's look at this one. 2y minus 8 equals negative 10. This is different. There's no x here. There's no x here. But can't we solve for y? Add 8. Add 8. So then we have 2y equals negative 2. Then divide by 2, divide by 2. So y is always equal to negative 1. So you'd say, okay, y has to be negative 1, but x can change. Because it didn't say anything about x. Yeah, because we don't have an x to plug into. Does that make sense? So the only way to do it is to just solve for it. Okay, awesome. Okay, this is the last one. So everybody, this stuff is really straightforward. You guys did awesome with the story problems. It's that same idea, it's just they're going to set it up for you. So it says, the cost C of renting a 12-foot truck for a day is $40, plus 35 cents times the number of miles driven. Guys, these story problems make sense. Think about it in real life. If I went out and I had to rent a moving truck, they're going to charge me an initial fee, $40. Then I'm going to have to pay an additional amount depending on how far I drive it. So this company only charged 35 cents per mile. So then it says, here's the linear function that represents it, which, why does it make sense? We're starting at 40, correct? Then we're going to add some amount of money, that's $40, based on the number of miles. So look, if I drive 1 mile, won't I only have an additional 35 cents? 2 miles, it'd be 2 times 35. Okay, you guys get it. Okay, awesome. So it says right here, what is the implied domain of the function? Domain is what you plug in. Input. Miles, right? Miles is the input. Yes, it's the independent. Miles is the domain. So what would my output be? Just, it doesn't ask that, but what would be the output or the range? Yeah, the cost. Yes. Okay, B, determine the y-intercept of the function. The y-intercept is always when? X equals 0, right? So then if x equals 0, plug it in. So it'd be 40. Now think about why that makes sense, everybody. If I was to model this, no matter what, if you rent from this moving truck, you are starting at $40. Does that make sense? Okay, cool. What is the rental cost if the truck is driven 80 miles? What would I do? Plug in 80, correct? What if on D it says, how many miles was the truck driven if the rental cost was $85.50? Where would I plug that one in? Where C is, and then, no, not where X is, right? This is the cost. You guys see? This is the ending amount. And then you'd solve for X. What? Well, you're just doing it in your head, but you're doing the math. Yeah. Okay, anybody confused? Okay, finish 3.1 as well. So these are the 3 lessons today. You have about 20 minutes.